Hi, Assalamualaikum. Today we want to explain to you guys about the transport of carbon dioxide in blood. There is three methods of transportation. Firstly, 7% of carbon dioxide dissolved in blood plasma, while 23% as carbaminohemoglobin and 70% transported in red blood cell as bicarbonate ion and moved to blood plasma. Firstly, we want to explain about 7% of carbon dioxide dissolved in blood plasma. Okay. In respiring tissue, partial pressure of carbon dioxide is high, while partial pressure of oxygen is low. Since partial pressure of carbon dioxide is high in respiring tissue, carbon dioxide will diffuse into blood plasma. Okay, in blood plasma, carbon dioxide will bind with H2O to form carbonic acid. Okay, then carbonic acid will dissociate into hydrogen ion and bicarbonate ion. Okay. So, hydrogen ion and bicarbonate ion will travel to the lung. Okay. It will combine to be carbonic acid. Then this carbonic acid will converted to H2O and carbon dioxide. Since in alveoli, partial pressure of carbon dioxide is low and partial pressure of oxygen is high, carbon dioxide from blood plasma will diffuse into alveoli.
Assalamualaikum warahmatullahi wabarakatuh. Today, I will explain transport of carbon dioxide, which is 23% as carbaminohemoglobin. We know in respiring tissue, partial pressure of carbon dioxide is high, while partial pressure of oxygen is low. So, carbon dioxide from respiring tissue will diffuse into erythrocyte, this carbon dioxide, and bind with amino group of hemoglobin, and then forming carbaminohemoglobin. And this red blood cell will travel to the lung. So this is lung and this is alveoli. So what we have here is that carbaminohemoglobin. This carbaminohemoglobin will dissociate into hemoglobin and carbon dioxide. And we know that partial pressure of carbon dioxide inside alveoli is low and partial pressure of oxygen is high. What will happen here is carbon dioxide will diffuse into alveolar space and carbon dioxide will be released to environment by breathing.
We are going to the last method, which is 70% transport in red blood cell as bicarbonate ion and move to blood plasma. Okay, now we look to respiring tissue, which is in respiring tissue, partial pressure of CO2 is high while partial pressure of O2 is low. So CO2 from respiring tissue akan diffuse into blood plasma and will enter red blood cell. And when it enter red blood cell, it will combine with H2O to form carbonic acid, H2CO3. This reaction catalyzed by carbonic anhydrase. Okay, this carbonic acid will dissociate to form H plus and HCO3 minus, which is bicarbonate ion. And this bicarbonate ion will diffuse out of erythrocyte, and will be transported into alveoli. Okay, here is alveoli. Okay, once it transport to alveoli, once it diffuse out, it will make it a positive charge. Then chloride shift will occur. Chloride shift is mean that Cl minus that come from dissociation of NaCl will diffuse into erythrocyte here. This process we call chloride shift. The function is to maintain electrochemical neutrality. At the same time, increase in H plus make erythrocyte become more acidic. So H plus will combine with with Hb. So H plus will combine with hemoglobin and form hemoglobinic acid HB. It is to prevent decrease in pH. Decrease in pH. Okay, decrease in pH. Okay, now we are going to alveoli, which is alveoli. In alveoli, partial pressure of CO2 is low while partial pressure of O2 is high. Okay. Just now that we say that HCO3 minus diffuse into alveoli. So HCO3 minus will combine, will diffuse into erythrocyte first, and diffuse into erythrocyte and will combine with H plus. So HCO3 minus will combine with H plus that come from hemoglobinic acid just now, and it will form H2CO3, which is carbonic acid. And this carbonic acid again will undergo reverse reaction, which is will dissociate into CO2 and H2O, and this process that catalyzed by carbonic anhydrase. So CO2 will diffuse out of erythrocyte and move into alveolar space, and it will be released outside.